I've prepared a whole bunch of Surds questions. Pause the video, have a go at your own time every time you see a new set of questions if you like. Okay, I'm going to go through 3, 3, 2, 25, 5. And I'll just leave that for a sec. By the way, you might be wondering, wait, what does that 2 mean? Well, actually, mathematicians are generally very lazy. They don't write a 2 there. If I had my way, we'd always write a 2 there, at least until you get to like university, because I just think it makes it needlessly complicated. Anyway, does that make sense? You might also be saying, wait, I thought this wasn't a surd because surds had to be square roots. Correct. I just thought I'd put that in there just to show the relationship to it. So in fact, let's ignore both those two and let's not bother writing that anymore. And breathe. Anyway, this is interesting. These are the two inverse functions. What's the square root of 25 times the square root of 25? How confident are you? What if I said, what's the square root of 9 times the square root of 9? Oh wait, the square root of 9 is 3. Square root of 9 is 3. So that's just 3 times 3, which is 9. Oh, it is, because you were possibly thinking, oh, I think it's just the same number, but I'm not sure. Hopefully, this little bit of working up here made you more confident. Okay, let's do the next lot. Is it a true or false set? Have a go in your own time. False. True. But you know what? I'm not even sure about that. We'll come back to it. What's the square root of 10 times square root of 10? It's not the square root of 20. Because that doesn't make any sense, because square root of 10 should be 10, which means that must be the square root of 100. And these two are definitely correct. By the way, the second one is just the first one rewritten with the times in it. Now, I decided to be honest here and say that my intuitive feeling is I'm not 100% confident about this. It looks a bit weird, doesn't it? So I'm just going to work it out. That would be 5 minus 4 equals 3. Well, that's not correct, is it? Okay, so no. There you go. By the way, if you thought that this one was correct, and it isn't, it's wrong, just to be clear, this is wrong, then that's because maybe you haven't fully realised that surds or square roots are special, and you have to be very careful with them. Some more questions? You might be thinking, oh wait, this is easy. I agree it's easy. We've kind of talked about this a couple of times already, just thought I'd spell it out again. Write in the form k over root 2. How do we do that? Well, let's just turn it into a fraction. And let's times the top and bottom by root 2. Which means that's 2 over root 2. Done it. That is now in the form because it looks the same. In the form just means make it kind of look the same. There's something on the top, and on the bottom is a square root of 2. Okay, let's look at the next page of questions. Okay. Pause the video if you like. I'm going to do this quite fast. I'm just going to write that as root 2 times root 9, using the fact that root A, root B is root AB. I can now cancel those, obviously leaving a 1 behind, because if you cancel when it's dividing it leaves a 1 behind, which is 1/3. Because the square root of 9 is 3. It says a rational denominator, so the bottom has to be a rational number, it can't be a surd. Okay, so that would be root 15 divided by root 2 root 15, so those cancel, leaves a 1 behind at the top, which is 1 over root 2, just tidying it up. I'm going to times the top and bottom by root 2, because that will I just know that that's a trick that will rationalise the denominator. There we go, root 2 over 2. Let's do the next one. Ooh, what are A and K? Do you know what? I'm just going to multiply out the brackets, because I don't know about you, I'm finding this quite awkward to look at. So then that would be 3 times 4 is 12, plus 3 root A, plus, I can't spell, plus 4 root A, plus A, equals 17, plus K root A. Oh, I can now by inspection, solve this. A is just a number, 12 is a number, 17 is a number, that's got to be 5. Has to be, in order for the two sides to be the same. And k root a has to be the same as 3 root a and 4 root a, so that means that k equals 7. Let's do the next one. Ooh, right in the form k root 3. I'm just gonna go as fast as I normally would here. That's root 2 root 3. I'm gonna put a times 2 at the end because that's what the root 4 is. Then that's root 2 root 100, that's just 10. These two cancel to make 2, so that would be 20 equals 40 root 3. There we go. Let's do the next one. Oh, I like these simplified questions. There's often little tricks that make them easier. That's a 3. They cancel, obviously. I've actually made this more awkward than I needed to, but I'm gonna keep going anyway. Doesn't matter. Root 2 root 3, and then that's 3 times 5, which is root 2 root 3 over root 3 root 3. Let's put the 5 in the front, which means I can now cancel the root 3's. Do you see what I mean? If I hadn't cancelled those root 3's at the start, I think it would have been easier. So it's just root 2 over 5 root 3. It didn't specify that I had to leave the denominator as rational, so I've left the root 3 there. But a lot of exams that I've seen, it specifies, like in the small print of on the first page, where applicable, leave all Surd answers with a rational denominator. So look at it, even if it doesn't actually say in the question up here, it might have said in the small print on the start of the exam paper, which obviously you don't need to read during your exam because you should have prepared in advance by reading that. Anyway, whatever. That's my answer. Notice also that 5, 3 and 2 are prime numbers. That's why I'm confident there's nothing else I can do. Is 3 root 3 equal to 9? I'm going to say obviously not, because how could I prove this? Let's suppose it said and prove. So that was the question. Well, 3 times 3 is 9. I know that's true. And 3 times root 3 is less than 3 times 3. So 3 times root 3, that's not equal to 9. There you go, we proved it. But I'm sure you could have proved it different ways. It's a solve question. I call this a make both sides look the same. Make both sides look the same question. Solve question. I know 3 on the outside, so I'm going to write that as root 9 root 11, because I'm planning ahead here, because now I know that I can have 3 root k equals 3 root 11. And then by inspection, I can say, oh look, because there's an equal sign in the middle, everything has to be the same, and everything is the same except for the k and the 11. Oh, well, that tells me that k must be equal to 11. Let's do the last question. Simplify. I love this question so much. If you're one of my students from the past who got this correct, well done. You are one of very few people that ever got it correct. A lot of students get this wrong. I'm just going to spell out, I'll do a very clear answer. This would be root 7 root 11 times root 7 root 11 equals, and then I'm just going to rearrange. It doesn't matter what order you write things in, yeah? If it's just times is. Oh wait, I know that root 7 is 7, and I know that root 11 is 11, so it's just 7 times 11, which is 77. Congratulations if you got that correct. Thanks for watching. That was, in case you're wondering, that was for me a combination of a lot of the very useful questions that I find help my students with Surds that are a bit unusual. I've not bothered repeating the very common questions that I see elsewhere a lot.